So, welcome to the next session. Agenda. The event features key speakers from various domains of semiconductor technology who will discuss important aspects of open source chip design and verification. Our next session is on the topic of an industry perspective on unlocking RTL quality with open source Lint tools. This session is delivered by Mr. Narahari, Senior Vice President at SignOff Semiconductors, formerly of Intel and LSI. Narahari will discuss the role of open source Lint tools in improving RTL quality and how they can be integrated into the design flow to catch errors early in the development process. He will provide an industry perspective on the impact of these tools on streamlining workflows and improving efficiency.
Good afternoon, everybody. This is Narahari here. The slight difference in the title, industry perspective on RTL lint checks. So here I will take a little higher level view of how the RTL checks, what future trends on RTL lint checks could be from the industry perspective. So what are the new trends in RTL lint checks looks like, right? So as the industry is advancing with AI playing a dominant role. So we expect RTL lint checks to also have checks called advanced AI/ML based checks. So machine learning algorithms to identify subtle design issues and predict potential problems. So I've listed here 4 RTL trends, and so I will take one example of the third security focus checks as an example, and to just for brevity purposes. And other changes that can come is excuse me. Okay. Other changes that can come from the architecture side would be on the chiplet specific changes, the chiplet specific checks, because there's a rise in chiplet based designs. So new checks are likely to emerge, especially with UCIe based inter-chiplet communication especially on power delivery and challenges associated with these architectures. So if you see the trends, the lint checks are pushed to the left, that is on the architecture side. So the chiplets specification is one example. And other would be security focused checks. For example, there's a potential vulnerabilities in RTL design that can happen. One example I would like to give in the next slide. So the security focused checks are increasingly becoming important because of the vulnerabilities that can exist in the RTL design. Side channel attacks, hardware trojans, all these are like now important things to consider, even in when you look at RTL design as such. So other changes that can come from the RTL lint checks or additions can come is the power optimization checks. Power consumption is always a critical concern. So new checks related to mitigate power related issues, excess power dissipation and power use in the new tools, new open source tools. One example that I give is look at the example of a counter. One second, is it here? Yeah. It's an example of an RTL. Yeah. So if you look at this code, this is a simple counter code, right? A Verilog code, and normally if you have check, probably if written well, then there'll be no lint error that is flagged for this. But if you look at the advanced checks or the future security related checks that can come. Next slide. Yeah. The security focused checks that can come here, it would be like development of new checks to identify potential vulnerabilities in this. For example, if you look at the code, there are some vulnerabilities here. For example, the counter values here is predictable. The count will be it can be predicted by side channel attacks. For example, a person who is monitoring the has a power consumption data can actually um, hack the RTL. I mean, can get into the code, right, and then can control. So the side channel attacks can happen based on power consumption data. So now what will happen is if a new link check comes, hey, that means open source is playing a big role in the innovation. Even the LLMs that we saw. Yeah.
It's there. It's there. No, people are saying what is not. So good that they. I can use, but play code.
Are you able to hear me now? I saw a message saying that audio is not.
Yes,
coming.
now it is okay. We lost you for a few minutes.
Okay. Yeah, just to recap, maybe I'll recap the last few slides.
No, you can start with this, I think. The other,
Okay.
This slide, yeah.
Okay. So I was talking about, say, on the left side, you have a Verilog code for a counter, which is like looks okay from a basic RTL perspective. But if you look at, there are there are hard coded values here. So future trends of future open source lints, security focused checks would be a part of our daily lives. Say here, there are potential vulnerabilities in this RTL design. There can be side channel attacks and hardware trojans because the count value can be predicted by side channel attacks based on power consumption data. So there's a predictability of a count value based on power consumption. So that can be, I mean, that part will be utilized by the side channel attackers, and then can cause havoc. So now, what would be the kind of solution would be implement a counter based on a cryptographically secure pseudo random generator to make it harder to predict the count value. So if you see that now the open source lint checks now are now getting into a wider area where architecture it is suggesting some architecture changes rather than just code. Rather than coding guideline changes or adhering to coding guidelines. So we can expect the RTL lints open, especially open source, is a bigger avenue to go after this kind of innovations. So we will increasingly see these kind of changes being like suggested by RTL link check tools. Okay, so that's the message that I wanted to give on the security focus checks. So we can give examples for other 3 checks as well. But I would say that this particular example is sufficient to capture what kind of changes that we can foresee. Okay. Okay. Other thing that I would probably touch about is a verification AI. We have seen that the previous speaker has covered UVM lints, right? So similar to this UVM lints, I mean, on the verification side as well, we need something like a verilator future versions, which involves AI. For example, intelligence built into AI, and probably, for example, right now, verilator has a built-in lint, and then once the lint is clear, it gives a compiled code. Similarly, there could be requirements on the verilator that the confidence and a must-have features that would have functionally working first-time silicon. For example, we have a fail-safe, or we have a fail-safe requirements. I mean, the RTL to, a design to be even if it fails, it is safe. Actually, this is more in the automotive segments where we have this functional safety checks and all. Similarly, we would require something like intelligence in the verilator tools. On the requirement traceability side, calling it as a safe bug, something like that. So because safe bug is something that, okay, a set of must-have features will work functionally, right, based on the verification that is done. And it gives much better decision-making power to the verification managers at the time of critical decisions like tape out, green signal, whether this set of must-have features will work, even when the regressions are running and then we don't have the full picture, or all bugs are not fixed. That kind of thing that would the lint and the verification environments would probably mix it in the future. So that would help required, or I think the industry trends would continue on that. So these are the 2 topics that I wanted to just touch base on this particular aspect on this in this seminar, right? So yeah, I think we have seen this. If you look at the latest news that are happening, open source LLMs, the DeepSeek ones, how they have actually attacked the problem of without foregoing efficiency. They have solved that into 2-level problems like distilled versions, and then attacking the distilled versions, pre-trained versions. So that way we may see more and more coming on the lint side as well with open source lint checks. Okay. That's what I wanted to cover. Yeah, any questions? You can put it in the chat and respond. Thank you.